Okay, 10 rapid fire questions coming up. Pause the video, lock in your answer, then I'll go through it. If you got it incorrect, please leave your name at the bottom in the comments. That way we can all name and shame you for not watching the previous video. Good luck. This is the foundation of the entire periodic table. How's it arranged? It's arranged by increasing atomic number. And the atomic number means number of protons. Elements are arranged in order of increasing number of protons. That fixed earlier problems in the periodic table, where elements didn't always fit properly when arranged by mass. So remember this clearly. Atomic number controls position. Question 2. What are horizontal rows in the periodic table called? Don't rush this. Rows go across. They're called periods. And here's why that matters. The period number tells you how many electron shells an atom has. So if an element is in period 3, it has 3 electron shells. Rows equals shells. Question 3. What are the vertical columns called? We've done rows, now think columns. They're called groups. Columns equals groups. And this is where GCSE questions love to test you. Elements in the same group have the same number of outer shell electrons. That means they react in similar ways. Same outer electrons, same behavior. So group number tells you the outer shell electrons. Now this is a key exam question. At GCSE level, what does the group number tell you? This is tested a lot. The group number tells you the number of electrons in the outer shell, but only for the main groups. At GCSE, we focus on the main groups. That's groups 1 to 7 and group 0. For groups 1 to 7, the group number matches the number of electrons in the outer shell. So group 1 elements have 1 outer electron, group 2 have 2, group 7 have 7. This is what links atomic structure to the periodic table. Group 0 is slightly different. They have full outer shells. Why do elements in the same group behave similarly? Think reactions. They have the same number of electrons in their outer shell, but that's not the full story. Chemical reactions only involve outer shell electrons. Inner electrons don't take part. So if two elements have the same number of outer electrons, they lose, gain, or share electrons in the same way. And that's why their chemical properties are similar. Same outer electrons, same reactions. Describe the trend in reactivity down group 1. Trend means what happens as you go down the group. Reactivity increases as you go down group 1. But why? As you go down group 1, atoms get larger. They have more electron shells. Those inner shells cause shielding. That reduces the attraction between the nucleus and the outer electron. So the outer electron is easier to lose. And group 1 metals react by losing 1 electron. So if it's easier to lose, reactivity increases. Why does group 1 reactivity increase down the group? This time, we're not just stating the trend, we're explaining it properly. Think about what actually changes as we move down. As you go down the group, the outer electron is further from the nucleus. There are more inner shells between the nucleus and the outer electron. These inner shells cause shielding, so the outer electron is less strongly attracted to the nucleus. Group 1 metals react by losing 1 electron. As you go down the group, atoms have more electron shells. This increases shielding. Shielding reduces the nuclear attraction between the nucleus and the outer electron. Because the attraction is weaker, the electron is lost more easily. So reactivity increases. That's the full explanation examiners are looking for. Describe the trend in reactivity down group 7. This is the halogens. What happens as we move down this group? Reactivity decreases down the group. So fluorine is the most reactive. Iodine is the least reactive. Group 7 elements react by gaining 1 electron. As you go down the group, atoms get larger. The outer shell is further from the nucleus. There is more shielding from inner shells, so the nucleus attracts an extra electron less strongly. Because it's harder to gain an electron, reactivity decreases down the group. Why are noble gases in group 0 unreactive? Think about their electron structure. They have a full outer shell. Noble gases already have full outer shells. A full outer shell is stable. Because they are already stable, they do not need to gain or lose electrons, so they just don't react. Helium is full with 2 electrons. The other noble gases are full with 8. This is where everything clicks. The periodic table is not random. It isn't just boxes on a page. It's organised entirely by atomic structure. So if you understand atoms, you understand the table. An element's position is determined by its number of protons. That's its atomic number. As you move across, the number of protons increases by 1 each time, but the shape of the table, the columns and the rows, that comes from electron arrangement. Here's how it all fits together. The atomic number tells you where the elements sit. The number of electron shells tell you the period. The number of electrons in the outer shell tells you the group. That's why elements in the same group behave similarly. They have the same number of outer electrons, so the periodic table isn't just a chart, it's a map of atomic structure. Once you see that, the whole thing makes sense. That's 10 rapid fire questions. If you're scoring 8 or more, you're exam ready. If not, rewatch and tighten the gaps. Next topic coming up, subscribe if you're serious about improving your grade. Mr. Knows, knowledge beats luck.